Anyway, so today we're going to talk about EVs and the landscape as we see it today. We're going to go through what constitutes a typical EV charger. And as I'm going to show you in a minute, what we call a charger is not really a charger. But the charge point implementations that are now spreading throughout the world, as you have seen on campus, there's several of them. We're going to see what's behind them, standards or lack thereof. We're going to talk about that a little bit. And like I said earlier, how we see that as part of the Internet of Things. The current implementations, and more importantly, where things are going in terms of future trends. And since we're doing this, I have to spend at least a minute on a commercial plug for my company. So you'll have to bear with me through that. At any point in time, we're going to reserve questions for the end. Patricia, what?
Yeah, we'll Q&A at the end.
Okay, so I'm going to try to limit this to about 45 minutes, 50 minutes tops. But I have my stopwatch going here just in case. And then we're going to continue with questions and answers after that. And okay, so with that, we can get into EVs. So EVs, as you have seen in the road, they're no longer a fad. They're here to stay. It's growing. The market is growing like crazy. Every day you recognize a new brand that comes out with a new model. By far, the most beautiful, most exciting vehicle out there, in my view, from a modern technology is a Tesla. That's one example of EV technology taken to the extreme in terms of outperforming a gas model. So no longer a fad. If you look at Europe, for example, which is the chart on the left, this is as of last year. If you look at last year, we had over 200,000 vehicles in Europe. This year, the expectation is a top 300,000. And you can see the graphs going up to about the year 2020, close to 1 million vehicles. The US is not far behind. This is data from last year. And pretty much is tracking the same thing, 220,000 vehicles as of June last year. And what's most exciting about this whole thing is the growth, which is phenomenal. So a car company in this space that has the right model and the right economics is going to do very well, right? Fortunately, that hasn't gotten there yet. And today we're enjoying the fact that there's more awareness about EVs, more mandates from governments. You have total cities, for example, Amsterdam, in Europe, where you cannot drive a non-electric vehicle downtown certain days of the week. It closes to gas cars, so you can only drive EVs in the city. And also it appeals to the good citizenry that we all are. You know, we're good citizens. Anything that's green, we want to do good for the environment. So EVs play to that, and so a lot of the sales are driven from that sense of responsibility to the environment. As far as the landscape is concerned, we can look at EV charging in two different areas, two categories. The ones that are used in the home, residential charging, and the so-called hosted, where you would have, for example, a convenience store or a shopping mall, a campus such as this. So that's what it's called hosted charging, where there is a service provider, and we're going to go over the service providers. So those service providers give you networks of those chargers and manage them in a way that the host only has to worry about getting maybe part of the fee on a monthly basis, and the service takes care of everything, maintaining the chargers and everything else. So again, residential and hosted. Now within residential, we really have two classes. Those where the owner is in total control. So most of the vehicles, when you buy them today, they come with a so-called level 1 charging or charger. So this is a device you plug into a standard 110 volt outlet. It's limited to about 16 amps. So it's going to take longer to charge than a so-called level 2, which is a 30 amp charger. Nonetheless, that's the majority of the chargers that are in place today. And then, of course, the commercial providers that we're going to talk about in a minute also have a subscriber model where you pay, say, $30, $40 a month, and you could charge not only at home, and they provide the equipment that you need for the home, but also when you go shopping, you can plug into one of their stations. So there's several of those already in the US. And then, of course, for the hosted, there's a number of companies in there, and there's some that are for profit and some that are not. So there's a mixed landscape of sorts in that area. But like I mentioned to you, the term EV charger for those devices doesn't really apply because the charging circuitry is in the vehicle. And this is something that's not really apparent to a lot of people because you buy this box from Home Depot or you get it from the dealer and you think all the thing is in there, in that box. But those boxes are pretty dumb. They're just really an AC relay with some safeguards to protect you from getting zapped by perhaps a short circuit or the ground fault, which is another possible fault that they have. But if we look at the diagrams here, I try to convey the three classes of chargers that we have today. So like I said, the EV charger itself is in the vehicle, and that's the box to the right. And the charging station, or the so-called EVSE, the supply equipment, is what's giving you the power with a relay contactor and some kind of handshake circuitry to handshake with the vehicle. But the battery, of course, is in the car. The conversion to DC is in the car. And then the modulation in terms of the current that the charging is going to provide to the vehicle is also in the car. So if it's a DC to begin with, we're going through some kind of inefficiency, right? Because you have to take AC, convert it to DC, usually 220 volts, and then you have to step it up because the battery is usually in an array of high voltage, right? So there's a better, more efficient way. Unfortunately, it's more expensive to deploy, and that's the so-called level 3 DC stations. So in the DC station, what you have is a variable DC supply. So you have usually a three-phase circuitry, very high current availability, converting to high voltage, and putting that high voltage directly into the vehicle. So obviously the charger, the safety precautions, and all of that would have to be different between the two types of chargers, right? So AC level 1, level 2, level 1, 16 amps. Typically a leaf would take 12, 13 hours to charge, maybe 18 hours to charge totally. Whereas with the level 2 charger, up to 30 amps, you could charge a Nissan Leaf in about 3.5 hours tops, okay? And that gives you 100 miles of range. Level 3 DC, you have some of the larger stations that you find in malls, and a lot of the Tesla stations are also DC, so they charge very quickly. You can charge a Tesla in 30, 45 minutes and go to 120 miles of range. So it makes a huge difference whether going AC or DC. Now, within the types of EVSEs, we have the so-called dumb EVSEs. I mentioned that they minimally have to have just an AC relay to commute or to turn on the power that goes to the vehicle. And some safeguards, such as overcurrent protection, ground fault shutdown, preventing current from flowing if the vehicle is disconnected. Obviously, you don't want a hot plug with 220 that you can touch and get zapped. And then to that, we add smarts, and this is where the IoT comes in. The smart EVSE allows connectivity, wired or wireless. Some of them come with an RJ45 that you could tie to a network directly, or some wireless implementation like we've done. I'll show you in a few minutes. But then they give you the ability then to remotely control the flow of current. Because the vehicle, even though the vehicle is the one regulating, there's a pilot signal that is inside the EVSE that is handshaking with that vehicle, and there's a protocol that takes it through certain steps. So with that pilot, you can tell whether the vehicle is plugged in, how much current the vehicle is demanding, and then limit the maximum current that the vehicle can take via that pilot signal. So there's a lot that can be done from a remote control viewpoint. And by far the best or the major benefit that you get from having this is the ability to meter the energy. The energy being delivered to that vehicle obviously determines how much you're going to pay. And this is where the economics are dictated, because when it comes to a utility, they might give you a special tariff or rate for charging late at night when the electricity is cheaper. And therefore, knowing and having control over that is of advantage to a user. Okay, there are many providers, and this is by no means an exhaustive list of providers. But just to give you an idea, most of these are US based. So we have, of course, Tesla with its own network of chargers. Initially set out for Tesla owners, but they're apparently opening it up to other vehicle owners. So Nissan or BMW might be able to take advantage of that. Easy Charge is a nationwide chain. ChargePoint is by far the largest one of the oldest in the US. Energy EVgo is one of our clients. EV Connect out east primarily. So there's quite a few of them. Their model is fairly similar. They sell you a subscription plan. So they give you an RFID tag and you carry that with your vehicle. And so whenever you find one of the stations, you approach it, you validate or get authorized through that ID. It works through the back end. They authorize that charge point, and then you plug in your vehicle, and then they monitor how much current you have demanded for that charging session. And then, of course, every month you get a bill for that. So it's a good model in that it gives you freedom in terms of going to different places to operate your vehicle. The one disadvantage is that there's no homogeneous single network or single authorization mode. So even though you can use them, you have the hassle of having to call when you go to a strange type of station. So if you subscribe to ChargePoint and want to use some other like EV Connect, and you have that hassle. But things are changing and things are getting better, and that's the good news. There are certain perspectives that we look at as providers. So we fit in the equipment supplier area, but the perspective can be looked at from a vehicle owner, from utilities, from the equipment supplier, and then I'm going to show you in the next slide two other constituents that play into this area. So from the vehicle owner perspective, what they want is, give me the car charged as fast as possible, the simplest possible way, the cheapest way, right? That's how a user will look at this, the vehicle owner. The utilities, they're afraid of the electric cars in that the stress that we can put on the grid can be tremendous. If everyone had an electric car and they came home at 3 in the afternoon, 4 in the afternoon, and plugged in on a hot summer day, the grid will come to stand still because they demand a lot of current from that grid, right? So the idea of metering, the idea of timing, the patterns of use, the idea of demand response, all those things play into what the electric grid and the electric utilities want from the electric vehicle charging network. As far as equipment suppliers concerned, there are certain challenges, still a niche market, and the big players have already entered that. So Schneider Electric, Leviton, General Electric, they all have chargers that you can buy at Home Depot or some other places. So it's not for the faint of heart. There's not for anyone just, a small entrepreneurial company that wants to get into this that can just do it quickly. The segmentation of the market is still very prevalent. So it's a new market, but still it's starting in a very fragmented way. Most of the chargers that are out there are dump chargers because when it comes to smart chargers, the smarts are usually provided on a custom basis for a specific charging provider, such as ChargePoint, for example, who commissioned to make their own chargers with those smarts. So the idea of finding an off-the-shelf smart charger isn't quite there yet. And then, of course, there's a lack of standards for so-called smart EVSEs. And I will talk about one of the standards that's emerging out of Europe this afternoon as well. From a service provider viewpoint, obviously, number one goal is to be profitable. These are businesses that are established for profit. And so to drive that profit, the equipment has to operate reliably and also at the lowest operating cost. You have to have the ability to meter those charging sessions, meter the amount of energy you're delivering. And you also have to be able to remotely access the data for your billing systems and so on. So the emphasis then overall can be summarized into simplicity. You need to focus on that business logic and providing excellent service to distinguish yourself from the competition. So that's the service provider. The host, let's say the 7-Eleven or the shopping mall that's hosting one of these stations, their perspective is, what's the value proposition? Can this make sense for my business? Is it going to attract more customers? Can I do this economically? Or is it going to be a loss leader for me? So all those things are the things that would then have a host, an institution provide such a service or host such a service. Obviously, if you're dealing with some new companies, how long those companies have been around? Are they going to be around tomorrow? Am I going to be stuck with equipment that nobody else is going to be able to serve? Right? So those are all the things that come through their minds in becoming a host. And of course, if they go out of business, can I get another company to host that, or rather to service that for me? Now, IoT, and we've talked about IoT quite a bit, and I heard a lot in this room about IoT, and that's probably what brought some of you this afternoon to hear about IoT. We have to kind of, every time we talk about it, we have to ground ourselves into what is IoT, right? And so I continue to go back to this definition, which is you have things that are connected, typically sensors and actuators, right? Things that bring you information, like temperature sensors, whatever, and things that do something, right, with that information. They turn a relay on or off, they open a valve, they do something, right? And then under that, there is some kind of a decision making that has to happen. So there's a framework of sort, and that framework is really what makes this whole thing tick. And without that having some usability for humans, it would not exist. So the premise is that all these things are fun, they're being put together, the technology sounds exciting, but if they don't do something for mankind, they're useless. So that's our premise. And so we have on one hand sensors that provide information, and we have actuators that act on information to do something, work for mankind. Now, we will look at sensors and actuators in a typical electric vehicle equipment, right? Supply equipment. And so, as I mentioned earlier, they're really, really simple from a technology viewpoint, right? They have things that safeguard from a safety viewpoint, and a couple of things that supply then the AC or DC to that vehicle to charge that battery. Okay, so from a sensor viewpoint, you need something that would then help you derive all the relevant parameters. What are the relevant parameters in a charging station? Obviously, the current that you're supplying, the energy is really more important and a more value, because that's what you pay, kilowatt hours, right? So the kilowatt hours that are being supplied to that vehicle, which involves obviously power over time. So power in kilowatts over time. And so to derive all of that, you need to measure RMS current and RMS voltage. And depending on the kind of power that you want to inform on, whether it's reactive, active, so you need to also measure the phase angle and derive how efficient the supply of that energy is to that vehicle. So all those are things that are sensors inside one of these EVSEs. Obviously, ground fault is a safety feature. You don't want to zap someone just because the ground failed. So you want to interrupt the supply of power and avoid someone coming in contact with a surface that's hot. The pilot signal state. Now, I may have mentioned that pilot is a signal that goes between the EVSE and the vehicle. It's really generated inside the EVSE, but modulated by the vehicle in such a way that it tells the charger what state is in. Things such as, yeah, you're plugged in, come through that pilot. Things such as, I want 20 amps now, come through that that pilot. So there's a protocol that accepted worldwide that guides the signal, if you will, that tells you what state you're in. It's called the J1772 standard. So that intelligence between the charger and the supply equipment and the vehicle is done through that pilot. And then obviously for a service such as NRG that we work with, having the ability to read a tag and authorize the charging of that vehicle is of importance. So RFID or near-field communications or some other means to get an ID into the system and validate it and then authorize the charging that can happen. From an actuating viewpoint, the actuators pretty simple. The main one is an AC relay that responds to that logic, and that signal is either on or it's off. So on, of course, implies that charge can be delivered, and all bets is off, you didn't get authorized, there's a fault, whatever it is, you have to actuate on that. And then some kind of user indicator to tell you what's going on in the process. A large scale EVSE networking, and this is where the whole networking comes in. So a service provider doesn't have enough to bill on with just a dumb charger that they apply or install on a campus or shopping mall. For that to be useful, you have to form a network that, based on some kind of back end, right? The back end applies certain business rules to certain information, and then based on that, you might get a bill at the end of the month. So to enable all of that, obviously you need the chargers that are providing the current, the EVSEs. In this implementation, we've utilized Zigbee as a low-level protocol that lets the charging information and the validation of the ID occur via a low data rate transmission, and then concentrated into what we call a site controller, which is the box that you see in the middle. So you could have a network, a personal area network, so a low data rate network using Zigbee, controlled by a site controller using Zigbee, and then that site controller communicates with the back end via broadband. And that broadband can be implemented either by Ethernet, by Wi-Fi, or by cellular, whatever is available on the premise. And what we have is the ability and the need to do these all three types of communication. Because again, you don't know what you're going to find on a given location. So the net result is that you can control these network of chargers on a point-by-point basis, authorize a user, authorize that charging session, collect the data, manipulate it, produce a bill at the end of the month. That's what this gives you. So the primary goal of something like this is availability, so the user can plug in and charge whenever they need to. Remember the perspective from the user. They don't want to know what's underneath all of this. They just simply want to go in, validate, plug in, charge. So the primary goal is that availability of data for the session. There are many ways to get that information to the back end and to control the VSE. So in the case of a large company implementing this, they opt for a custom. In absence of standard, you roll your own. And that's what they've done in this case. So there was no real need for data standards when you're implementing and everybody's doing that, and the host can be comfortable with that. Once the host becomes uncomfortable with that, that's when standards have to emerge. And that's exactly what's happening. Before I leave this topic, this is an actual setup for real in Houston, the Energy Stadium. You heard of that in Houston. NFL?
Yep. Houston, Texas.
Houston, Texas. So there's the Energy Stadium. There's a network of chargers controlled in this fashion, implemented with the site controller that I showed you before, and that Zigbee charger network. And there's many points throughout the U.S. implemented this way. And so this all has been replicated quite effectively. So the idea is with simple hardware and standard, with an implementation of firmware that uses standards such as Zigbee, you can implement such a network quite effectively. Now, for whatever reason, we tend to be late in the game when it comes to standards, and this is another example where the Europeans have been ahead of the game, providing standards, and not to be left behind. We are adopting it now, but it's kind of in an early stage. So this is a protocol that's now on version 2, and the protocol is called the OCPP for Open Charge Point Protocol, and it defines the interface between a charge point and a back-end system. Okay, so remember that chart that I showed you earlier, that diagram. You have a back-end, which is a central management system, and you have a network of chargers. So this protocol actually guides that implementation and the communication between each of those charging points and that back-end for the benefit of the host that is using that system, right? This defines then the messages and message exchange of the authorization, when the device boots, when the device goes into diagnostics. So these are kind of functions that the protocol defines. Stopping the transaction, because there are cases when you want to stop the charging for whatever reason from the back end. Reading the meter values, providing some heartbeat to ensure that things are communicating. Changing the availability. So typically in a private network such as this, given the subscriber, they may have tiers of service. So in some cases you want to limit the charging that someone can have. So if you have, say, gold status, you can charge anytime, anywhere, or you may have your own private point. So all that logic, all that business logic needs to be managed. And the protocol actually makes provision for a lot of that, which is very, very nice. Getting diagnostics, and so on and so forth. So a lot of detail behind that protocol, very, very powerful. It's called the OCPP protocol. Here's an example of how that gets implemented. So you have a central system, that cloud that I was talking about, and then you have charge points distributed throughout a geography. And obviously with this protocol, it doesn't matter where the charger point is, because in the messages, you have embedded things such as the ID of the EVSE, the location of the EVSE, the starting time, the time zone in that area. So you have all the pertinent information to manage that network of charge points embedded in that protocol. So you can manage a charge point that may have multiple connectors, maybe only one connector, it doesn't matter. So from a physical implementation, a lot of flexibility. But most importantly, the benefits that OCPP brings in to charging stations is what we list on the right. We've been talking about the perspective from the host. Having a protocol such as this allows the host to be less vulnerable to the suppliers, the individual suppliers, and their longevity. So they can come and go, but if the equipment is compatible with something like this, they can maybe go to another supplier and be okay, or maybe they implement their own. And that's also very, very doable and possible. Because of that, it encourages competition, which in turn, or because it provides more opportunity for innovation, lowering the cost, and provides more choices. So things may not be just limited to the big players, but maybe an entrepreneurial company like ours can come in with take advantage of this and be a player in the field. Improving the software availability. Obviously, having firmware and software that drives all of this is the majority of the investment that you have to make on something like this. So Standards tend to drive the more rapid availability of that because it lets you implement at a lower cost. And of course, all of that results in the infrastructure expanding because it becomes cheaper to put these charging points throughout different geographies. Now, for us, the most exciting part of this whole thing is we are a connected home company. We started as a home automation company. We have over 50 products in home automation space, from smart plugs to load controllers to temperature sensors, gateways, a whole bunch of things. And putting the EVSE in that network is exciting because now a homeowner can, from the couch, see, okay, tonight it's going to charge between this time and this time. Is that the right time? Yes. And you can approximate your electric bill because the time of use, maybe you have your rates already loaded into the system, so you can do some predictive things. So it integrates with this whole concept of the connected home very nicely. But there's not a single EVSE that you could buy out there that is designed or ready to be connected to your home automation system. And we intend to change that. So a basic implementation that we've come up with is we sell a gateway. It's a little box about the size of a pack of cards, and that gateway is a Linux system with a built-in Zigbee radio, and it's got Wi-Fi and Ethernet connectivity. It becomes a hub for your home automation system, and that hub can communicate with the backend. Or you can leave it standalone in your home. It doesn't matter. But via Zigbee, we can control the various things that turn things on and off. So we have smart plugs that can do a level 1 charger very easily. Or a smart socket, which is good for 16 amps. So you could have one in the garage, plug in your level 1 charger, and all of a sudden you have smart EVSE that you can measure the energy is being delivered. You could set up timers on it, whatever. So the same thing with those two devices. Now, level 2 we can control with a larger load controller that we make. That one requires an electrician to install, but the idea is still the same. You have metering, the ability to meter what you're delivering, and control it on and off. And to those things, you can plug in a level 2 charger or level 1 charger. So that's how we see a very easy transition of EVSEs into connected home, the connected home. The next step is actually building in the controller, and we've done this already with a charger that comes out of Taiwan, where we build in the Zigbee controller into it. So you can go directly from the gateway to that. Now, I think as we look at the future, and with the thought that the charger is really in the car, in the future, what's going to make more sense is the car connected directly to the grid, right? From both physically and from a wireless, from a data viewpoint. Because the charger is really, the vehicle can also monitor the charging and can set up timers and all of that. So in the future, what we see is that home automation, that home connectivity going directly to the vehicle. But who knows how long we'll have to wait for that. Okay, so IoT. We're talking about IoT now. IoTing, maybe I should put an apostrophe in that, IoTing, or IoTing. Doing IoT is getting easier. I think a year ago, it was a big mystery, right? And people would have all kinds of definitions. But today, you don't have to look too far. And if you go to Amazon Web Services, just at the last AWS event, they revealed their IoT framework, and it's really a collection of services that they provide. So the devices can authenticate, they can subscribe their data to services, and you can write front ends to analyze the data. There's built-in analytics and all of that. So AWS is the giant in this area. Okay, so it's the latest entrant. They had most of the things set up, but they complemented them with the acquisition of a company called M2 Telemetry just a few months ago. So major player, you're going to see a lot from them in this area. But the people that will benefit from that, it's us, because it will be easier to come up with solutions for connected devices. Google has had this platform for a while already for Internet of Things. And the reality is that these things provide basically three things. The ability for a device to connect to them and push data, the ability for you to do something with that data in terms of analytics or display, and the ability to then put whatever front end that consumes that data or do something with it. Okay? So AWS adds the concept of the rules engine, which is very, very nice, because that was a factor that was missing on some of these things, is the computation ability to take that data based on conditions and then do something. So as information comes in, they can transform it through a set of rules into a given action. And that's pretty powerful. The other two big players, Microsoft, is kind of behind in this whole thing, so they're trying to catch up. IBM has been around for a while, and very quietly has been delivering this framework called Bluemix. And as far as my opinion is concerned, they're the most advanced. Okay, they're truly oriented to devices. Literally, in less than an hour, you could implement an IoT solution with any sensor that you want. So you could take an Arduino and put some sensors together, and within an hour, you have them talking to their cloud, and you can display data in a portal dashboard. And that's pretty good. Okay, so IoT in our book, it's all about connections and APIs, right? It really boils down to those two things. Why do I say that? Well, connections is really what allows you to have a device get data into a service and get data out of that service in some meaningful fashion. That's a connection. So whatever you want to call it, the low-level protocol or what have you. And then API is really the languages that you're using to consume those services. So a service to do analytics is all about an API, the definition, if you will, the language to get that data and run it through a graphing engine or what have you. So we're all in good times because a lot of these frameworks are now available and the number continues to grow. And just like we see this new protocol at a higher level for EVSEs benefiting that, we see all these APIs for services such as AWS and Bluemix becoming richer and making those services available for many, many providers, right? Now, when it comes to the lower layer, and we cannot ignore that there's a stack that's been out there for a long time, the TCP/IP stack, the stack of the web, the stack of the connected points that we use by the billions, right? So until recently, this idea of having something that's always on and asynchronous wasn't really there. So the language of the web is being this traditional HTTP request, HTTP response. So a web browser sends a request for information to a server, the server obliges, and then the browser renders information on that browser. So that's still very prevalent today. So it's a polling, give me this, give me this, give me this. So the idea of having a server pushing data, as you would have a device. So what if the Internet of Things was all these things saying, hey, do you have new data? Oh yeah, here's the new data. Imagine the traffic that would develop from that, and it would be impractical. So all these new protocols that we're seeing alleviate that issue. And they have two things in common, which is the ability to push data to a server, right? And the ability to do it anytime with this so-called always-on connection. So a very huge shift in paradigm on the web and web technologies is what's making all this whole thing possible. And the two things that in my book embody this paradigm shift are two low-level protocols. One called the MQTT, stands for Message Queuing Telemetry Transport, and Websockets. Websockets getting all the rage. I wouldn't say that they're either or they're equivalent. Websockets is another layer on top of the TCP/IP. Both of them really can be put on top of a TCP/IP stack to implement that transport protocol. But MQTT is designed for very small footprint, very fast speed, and very high simplicity. So it's really ideal for devices. Now a little bit about them and WebSockets. So as I mentioned, the language of the web up to now has been polling, long polling and streaming, right? So you have requests, a system of requests and responses. Whereas a WebSocket, events can actually push a message out to a server. So the client-server relationship from a communication viewpoint is not really as strictly adhered to. It doesn't have to be. You don't want it to be. But you want information to be asynchronously pushed when it needs it. MQTT takes a slightly different approach. I have no idea what's going on here. We have a scrambling or something. So MQTT takes a different approach, which is rather elegant. So in MQTT, a device as a server is designated a broker of information. And then the devices can be either subscriber or publishers of information. So let's say a sensor, a temperature sensor, can be a publisher of information. So whenever it has a new reading, it communicates with that broker and says, hey, I'm publishing this piece of data, right, to this particular box that you have. So the broker has a set of mailboxes, if you will, or folders, and it sticks that information into that folder. So now you have it nicely organized. Now, a subscriber, which is a consumer of information, or sync, simply subscribes to a particular piece of information. So let's say I want to subscribe to that sensor. So whenever that sensor pushes a new piece of data, the broker obliges and sends it to me. So it's a beautiful, elegant little system which serves the Internet of Things extremely, extremely well. Now we're an IoT company. So before we close this, I wanted to tell you a little bit about us. We've been around for a while. We provide just about everything IoT. We have gateways. We make actuators of all kinds, from 30 amp relays to 15 amp smart plugs. Sensors of all types, such as temperature, humidity, light level, valves, and so on. And we take the entire framework, if you will, from beginning to end. We have services that we provide to custom companies or larger companies. And of course, in some cases, we just provide the devices. We're members of the Zigbee Alliance, and we're proud to have the very first EVSE controller, which is Zigbee certified by the Alliance, and that's our device. With NRG, we are the first ones to deploy a Zigbee-based network of EVSEs, which is used nationwide. Member Calit2, of course, that's why we're here today. The Zigbee Alliance and the OCPP that I mentioned. And this week we're forming Smartenit.io to maybe put more emphasis on IoT and kind of distinguish the connected home and the IoT business. The IoT business tends to be more custom solutions for OEMs, and that's slightly different from what we do for consumers and others. Anyway, so that's it. So in summary, I just wanted to leave you with some thoughts, and I'll open it up for questions at that point. But hopefully you recognize that the time for EVs is now. They're here to stay. You'll be driving one soon if you're not already. Once you drive one, you fall in love with them. You don't want to drive anything else. I lost mine to my wife, so I can't drive anymore. I cannot afford the Tesla, so I'm waiting for that. They are the ideal things to be connected through the IoT, but I think the connected vehicle makes more sense in my book. Even though we haven't had that many standards, they're proliferating like crazy. EVSEs are being deployed everywhere, okay? Because it's all about the business model. So if there's a service that makes money, there's a host interested in attracting more customers, if there's a campus where you want to be green and be good for the community, they're going to be there. They're going to be there, and the growth is exponential, as I showed you from the other graphs. The residential EVSEs are well suited for this connected home paradigm that we're driving. And so, and hopefully you also, if you came for the IoT part, you realize that these are exciting times for IoT, especially for the proliferation of those services and availability at very low cost for those services. And then the question, of course, is always what's going to continue to drive further efficiencies in this area. So that's it. Hopefully, I didn't keep you too long, and hopefully we'll have some time for questions.
Let's thank Al for his presentation. And we're looking forward to Q&A. Any questions?
It's got to be at least one.
I'll see the pod here. Can you tell us why? I know a lot of your products are based on Zigbee. Can you tell us why you prefer Zigbee as communication?
Prefer against
let's just say going over Bluetooth or a number of the other ones out there, such as Wi-Fi. Why is Zigbee applicable for IoT or particularly good?
Okay, good question. There really aren't that many standards to choose from, and when it comes to doing things with energy, one of the things that drove us was we need connectivity to smart meters. Smart meters are all based on Zigbee, and so it made sense if you wanted to capture that market and enter in any kind of serious way. It made sense that our products would be compatible with electric meters. And so in our Zigbee implementation, we have a so-called HA profile using 1.2, and then we have the smart energy profile that is totally compatible with smart meters. You take our gateway, for example, and you can connect it. If you're an Edison subscriber, you can get our gateway and read the meter remotely, and create rules to turn things off when your consumption drives to a certain point and things like that. We haven't done a lot of marketing in that area. The other thing is that Zigbee is really based on 805.14.4, which is the standard that's driving Thread and all these new protocols that you hear from Nest Labs and Google. 6LoWPAN is really the IP implementation of that. So Zigbee gives you the command and control layer, and it does it extremely well. Okay. So as opposed to some of the other protocols that don't give you that clear command and control ability, they have this very well-defined concept of clusters. So all those things played into that decision, and we're happy with it because now the standard has been adopted more and more worldwide.
Thank you. Any other questions?
Do your devices allow their cars to sell energy to the grid too, or not? The stations of chargers that you get? Can they sell, for example, in a moment that the demand is really high, maybe the owner of the car can actuate as an independent provider and supply energy to the grid?
Right, that has been actually explored. Not a lot of implementations where that's happening, but the idea is that you have a battery in those things. So if the car is not charging or is not being driven, you have a lot of energy stored in those many kilowatt hours, right? Available that you can put back on the grid. But there's a lot of considerations for that. Warranty in the battery by the dealer, by the car maker, infrastructure in terms of putting it back. Because most of those things are one way only, so the car can get charged but putting it back is, the logistics aren't quite there. But in theory, that could be done, and there's a lot of programs going on right now. University of Delaware, under grant from NRG, has been working on that a number of years, and they have a large research program in that area. So the whole storage thing is of great interest to the utilities. Because again, the tendency is that you're producing to the maximum possible demand that you have, but you're not going to have the demand at all times, right? So what happens to the energy? So if you have ways of storing it and supply it at periods of high demand, it's a good way to make things more economically.
Any other questions? Well, I would like to give Al a token of our appreciation for
Oh, thank you.
having come and speak to us today, and
Thank
our
you.
reception's outside. Please join us. Thank you very much.